First chapter, I think it's deleted from the topics.
First chapter means not from the chapter 1. We will start from the second chapter, that is units and measurement. There is nothing more information related to physics in your first chapter. Okay?
So we start from the second chapter?
Yeah.
Okay, sir. Yeah.
Okay, sir.
In first chapter, there is some relation about a scientist, their discoveries, their date of birth, date of death, how much he has achieved, and so on. So mainly there is one term in that particular chapter which you have to learn, like fundamental forces and conservation laws. We will explain it later. Okay?
Which one?
First chapter.
Okay.
In first chapter, you have to learn just only one thing, fundamental forces. Okay? So, the first thing in this particular chapter, second, is units and measurement. In this particular part, first we define physical quantity. Do you have any idea about this particular term? Muhammad Shakirullah.
Yes, sir.
Faiza. Do you have any idea about this particular term? Aisha Rahman.
It's a property that can be quantified by measurement or, I mean,
Okay. I'm defining some term, how to define these terms. Let's say if you have to calculate some mass of a given quantity, it would be like some 5 kg. So for the calculation of this particular term mass, we define a particular numerical value and a unit for that particular measurement. Similarly, for the calculation of time, like for an event for just 2 hours. So 2 is just numerical value and hour is its unit for calculation. Now, if I have to define some more term like feeling, emotion, hunger, could you define any numerical value or any specified unit for the measurement of these terms?
No.
Why so?
Because they don't have any units, and though we cannot give them unit and we cannot measure it.
Okay, so these are just defined on the basis of relativeness and how much larger proportion and how much smaller proportion. So for these, we can't define any numerical value or specified unit for its measurement. So from this, we can conclude if a quantity is measured in terms of some specified numerical value with a specified unit, we call them as physical quantity, and the other one are not as physical quantity treated as. Is it okay? So from this, we can define this particular physical quantity as the quantity which can be measured directly or
Indirectly.
indirectly in a unit, and in terms of which laws of physics can be defined. are called physical quantity.
Yeah. And I think, sir, there are two types, yeah, of physical quantity. One
I'm
are,
explaining that.
okay.
Okay. So first I have written directly measurable and the second one is indirectly measurable. What it actually means in this particular term. Suppose you must have learned speed. Have you remembered the formula to calculate speed?
Speed, yes.
Yeah.
Distance
Tell
by
me. Good. So for the measurement
By
of speed,
time.
good. Distance divided by time taken.
v is equal to
So
a
from
square.
this particular term, if you have to calculate distance, it is just independent of our other term. We just need a meter scale and start counting from the start of journey till they get ended. Similarly, for the calculation of time, we just need any stopwatch or watch. Start that particular stopwatch till the event gets started and stop till the event get ended. So for the calculation of these two terms, we don't require any other physical quantity for its measurement. But for the calculation of speed, we must need distance as well as time for its calculation. So on the basis of this particular term, we can define physical quantity as two different parts. First, the thing which are directly measurable and the thing which are indirectly measurable or which can depend on other factor for its measurement. So for directly measurable, just as distance, which is independent of all other terms, similarly time, which is independent of all other terms. So we can say the quantity which are independent of other quantities are called directly measurable. But here, like speed, which depends upon distance and time for its measurement. So we call this particular speed as indirectly measurable or dependent term on other term as well. So we can say this is dependent on other for its calculation. Is it clear to everyone?
Yes.
Yes, sir.
Faiza,
Yes, sir.
is it clear?
Sir, sorry, can you just say once about direct and indirect?
Directly measurable, the thing which are independent of other quantities like distance, time, mass, and so on.
Yeah.
So in physics, this particular directly measurable quantity are called fundamental, and this particular indirectly measurable quantities are called derived. Okay,
Okay.
just write down. Jovan,
Yes, sir.
any doubt?
No, sir.
Okay.
Sir, write down this notes.
Yeah. Kezia Biju. Any doubt? Have you all written?
Wait a minute, sir.
Done, sir.
Okay.
Yes, sir, finished.
Okay. Have you all written? Abhi?
Yes.
Yes.
Okay. So the next part in this particular term we define is fundamental quantity. Suppose when you have started learning in your childhood, like for English language, which particular step you have first started learning
Yes.
for knowing this particular English language? Jovan?
We started learning alphabets.
Good. So the first thing in this particular or any of that language, we start with the alphabet of that particular term, like A, B, C, and so on to Z. The next step is to just rearrange them to form words like apple, ball, cat, and so on. Next, we start rearranging them to form sentences, passage, paragraph, letters, and so on.
Yeah.
So from this, we can define the most fundamental part of this particular knowing English language is the alphabet. And all other terms are just based on these particular alphabet. Without alphabet, we can't define these terms. So this particular alphabet for the language of English or any of the particular language is called fundamental, and rest of the all part which are based on this term, we can call it as derived part. Is it clear?
Yes, sir.
So from this, we can conclude fundamental quantities are those quantities which are independent of other quantities. The physical quantity, which are independent of other quantities, are called fundamental, and rest of all which are other than fundamental are called derived quantities. So we define fundamental quantity into two parts. First is base quantity, and the next one is supplementary pointing. You might have learned, or you must have heard from somewhere, the oldest branch of physics is mechanics. In this particular mechanics, we learn just three things: mass, length, and time. On knowing just these three terms, we would be able to calculate speed of body, velocity, acceleration, force, momentum, kinetic energy, work done, or any of the terms which are related with this particular mechanics. So in earlier days, these particular three terms are treated as base fundamental quantities. Okay. So first base quantities are mass, length, and time. But due to advancement of physics, some more quantities were introduced in this particular section, like temperature, amount of substance, electric current, And the last is intensity of light. So we have in total 7 base fundamental quantity. Okay, is it clear to everyone?
Yes, sir.
So for this particular base fundamental term, we define some unit for its calculation. For the calculation of mass, SI unit would be kilogram.
Kilogram,
Next, for the calculation of length, it would be
meter,
meter. Similarly, for time,
second,
temperature,
Celsius.
no, it's Kelvin.
Oh, so sorry.
Amount of substance in terms of mole. Electric current, joule,
I. No, sir, sorry.
joule. Tell me the unit of electric current. Kezia,
Sir, lambda.
Ampere.
good. Similarly, intensity of light, candela. Now we define some term which is called dimension. I will explain you later what actually dimension mean. But in terms of dimension, this particular mass is represented by capital L. For length, we use capital L. For time, we use capital T. As these three were the basic term in earlier days for this particular mechanics. So we just take their initial as the dimension of those terms. Now, for the later on display discoveries like these particular term, we take their unit. For Kelvin as K, amount of substance, we take mole, electric current, ampere, and intensity of light, candela. I will explain you later what do you mean by dimension. Okay. Any doubt till now to any one of you?
Yes, sir.
Just write it down. Have you all written?
Only
Done, sir.
Abhi?
just finish, sir.
Joel?
Still writing, sir. Done, sir.
Okay. So the next part is supplementary pointing. In supplementary pointing, we define two terms. First is plane angle, or the angle which is formed on two-dimensional surface, or just surface, plane. Like, suppose you have a circle and this is your radius.
Radius.
This is the angle subtended by these two radius from center, and this is your length of arc at its boundary. So we have learned in our class 10th, there was a formula in relation of this particular length of arc with radius and theta. Have you remembered? Faiza? Do you know the relationship between these two terms? How to find length of arc in relation with radius and theta? Kezia? There was a formula, length of arc is equals to theta divided by 360 degree into 2 pi r. So this will define you the length of arc from its boundary, which is subtending some angle theta at its center. Till this particular part, we have used angle as degree measurement. Now we have some other unit for the calculation of that particular angle, that is radian measurement. For one complete circle, the total angle is 360 degree, but for one complete circle, total angle in terms of radian is just 2 pi. So on equating these two terms, I'm defining you one formula to convert degree measurement into radian measurement. Just multiply degree measurement by pi by 180 degree, it will convert into radian measurement. Okay. Suppose if we have to convert 30 degree in terms of radian, just multiply it by pi by 180 degree. 0 and 0 cancel out. 3 and 6 times will be equals to 18. So we're left with just pi over 6 in terms of radian measurement. Is it clear to everyone?
So in this case, we can open the pi.
Yeah. If you have to calculate in terms of numerical value, you can use pi is equals to 3.14 or 22 by 7.
if like this questions comes in some exams, can I give like this without obtaining the pi?
Yeah, you have to write in most of the exam as in terms of pi. But
Oh.
if there would be some numerical value, you have to just convert the value of pi as 3.14 or 22/7 to simplify this particular fraction. Okay, so for this particular equation, if I convert this particular 360 in terms of pi, it will be just 2 pi times 2 pi into r. 2 pi and 2 pi gets cancelled out. So we're left with thus theta times of r is equals to L. So from this, if we calculate theta, it will be just equals to length of r divided by radius. Here, theta is measured in terms of radian. So this will define you the measurement of plane angle or the angle formed on any surface. Is it clear to everyone?
Yes.
Joel,
Yes, sir.
there is one more measurement related to this particular angle, which is called solid angle or three-dimensional angle. Suppose if you're sitting in a room, just see at the corner of your room, it will look like some portion of the corner like this. This will be your rooftop, this is your side wall, and this is your another side wall. These three faces will forming a cone at corner.
Really? Yeah. Okay.
So that particular angle is measured in terms of some other unit, and that angle is defined as solid angle. So if I define arc in front of that particular vertex like this,
You are giving 4 radius, yeah?
if I have assumed a sphere and I have cut a small section from its center, so it will look like some area in front of it, and the angle inscribed at the center, we call it as solid angle and represented by some ohm.
Yeah.
This is your distance from the vertex to that area A. So we define solid angle is equals to area in front of it over r square. So this particular solid angle is measured in terms of unit that is called steve. Is it clear?
Yes.
Faiza?
Yes, sir.
Kezia, any doubt?
No, sir.
Okay. Just write down. Have you all written?
Just a minute, sir.
Yes, sir.
Yes, sir.
Kezia, done?
Yes, sir.
Further finish.
Okay. So we have just defined all the dimension, all the fundamental pointing, base pointing, and supplementary part. The next important part in this chapter is to define dimensional analysis. For this particular dimensional analysis, we have to first define what do you mean by dimension, dimensional formula, or dimensional equation. You must have learned in your mathematics part, geometry. There, for the calculation of volume, area, perimeter, circumference, we define some term, length, breadth, radius, depth, height, and so on. These parameters will define the area, perimeter, volume related to that particular geometrical figure. So these terms in this particular geometry, we call it as dimension of that particular geometrical figure. But in terms of physics, dimension have certain different meaning. Suppose, as we have explained, speed is nothing but distance divided by time taken. So distance is nothing but the measurement of length. So for the measurement of length or for the representation of length, we can represent it in terms of capital L. Similarly, for the representation of time, we can represent in capital T. If we bring this particular term to the numerator, it will become L T to the power -1.
-1.
Is it clear?
Yes, sir. This is to find the
First-
dimension. Find the dimension of
First, yeah. First, I have defined this particular distance is nothing but measurement of length. So for the measurement of length, so length can be represented as capital L. Similarly, for time, we define capital T. If we bring this particular denominator part to the numerator, its exponential will change to -1. Now, what this particular representation is actually defining you. This particular length is nothing but in terms of meter, is measured in terms of meter. Similarly, for this particular time, we can define it is second inverse. Now, this whole part is nothing but meter per second. Okay,
yes.
you must have learned about this particular part, the SI unit of speed. So from this, we can define the SI unit of speed is meter per second. Now, this whole is defining you something. Any of the physical quantity like speed, if it is represented in terms of fundamental quantity to the raised power like 1 to -1 or -2, such that this particular representation will define you the SI unit of that particular given quantity. So this representation is called dimension. So dimension of a physical quantity is nothing but representation in terms of raised power to the fundamental quantity, and that representation will define you the SI unit related to the given quantity. So this representation is called dimension, dimension formula, or dimension equation. Is it clear?
Yes, sir.
Juan? So from
sir.
this, we can define dimension is nothing but the representation of any quantity in raised power to the fundamental quantity such that it defines their SI unit. Is it clear to everyone? Faiza?
Yes, sir.
Okay. Now I'm defining some basic or fundamental dimension related to some term. On the basis of that, you would be able to define dimension of all other terms. So some basic dimensions or dimension formula. The first is length, breadth, depth, height, width, radius, diameter, distance, displacement, and wavelength. This all would define you the same term, that is measurement of length. So we can simply write it as dimension in terms of L. Okay, the next part is area. For the calculation of area of the any geometrical figure, we just multiply two different lengths. So their dimension would be nothing but L square.
Yes.
Similarly, for the calculation of volume, we just need three dimension of length. That means length, breadth, and height. So it will become L cube. Okay. Now, suppose if you have to calculate density, you know the formula to calculate density?
Sir, it is mass divided by volume.
Good. Mass divided by volume. We have dimension formula for mass as capital M, and dimension formula for volume
LQ.
is L cube. If you bring this particular to the numerator, it will be ml to the power minus 3. Okay,
Yes.
just write it down.
So done.
All written.
That's it.
Yeah. Done.
Yes, sir.
Yes, sir.
Yes. Yes. Done.
Okay.
The next part is speed, velocity, and speed of light. All these three would have same unit and having same dimension as LT minus 1. Now, on the base of these three terms, you would be able to calculate acceleration, gravity, gravitational field. How to define this particular acceleration? You must have learned acceleration is nothing but change in velocity by time taken.
Yes. Delta velocity change of velocity divided by time.
So just put the dimension and try to simplify it to find the acceleration.
L.
Just try to solve.
Sure. It is
Yes,
acceleration LT to the power of -2.
good.
So it means this L to the power of -2 dimension. It's used for gravity and gravitational field also. Yeah.
Yeah. These all three would define you the same dimension. So I'm writing in combination or pair for all those quantity representing the same dimension. So for the next part is we have to define force. You must have learned the formula to calculate force is
Yes.
nothing but mass times acceleration.
Acceleration.
So just put the dimension of mass and we have dimension formula for acceleration. Just rearrange them.
What's it? Means this. So it's MLT -2 because acceleration is given LT -2. So M mass means capital M only and MLT
Good.
minus.
The next part is work done. Joel, do you know the formula to calculate work? Kezia,
What, sir?
do you know the formula to calculate work done?
Sir, can I say?
Just 1 minute. Kezia, tell me the formula to calculate force work done.
So work done is force into displacement.
Force into displacement. Good. So work done is nothing but force into displacement. So we have dimension formula for force as this
MLT
and
minus.
dimension formula for displacement. Just put their dimension and try to simplify them. You would be able to calculate the dimension formula for work done.
So it is ML squared to the power of -2.
Good.
So now can you give us this time to write this? Speed velocity, speed of light.
For force, it is nothing but mLt to the power minus 2. For displacement, it's just L.
Only
So
L.
this L and this L will becomes L square e raised to the power minus 2. Okay, Jovan?
Yes, sir.
Now, all of you send your answer in your chat box. I'm giving you one more problem. Next is pressure, stress, modulus of elasticity, that is Young's modulus, bulk modulus, and shear modulus. Next is volumetric energy density. This particular term is represented as half or half b square over mu naught. These all represent the same dimension.
So
Abhi, tell me the formula to calculate pressure.
me?
No. And all of you send your answer in chat box.
In the application or where?
Chat box. Just use chat box.
Sir, can you repeat the question?
I'm asking. We have to define the dimension formula for pressure. So first, pressure is nothing but force divided by area. So just put the dimension and simplify them and send your answer in chat box. Have you all calculated? Yes.
Should I send to MZ?
Yeah.
Yeah, okay, sorry.
Good. Joan, send me your answer. Send your answer to MZ in chat box. Faiza, any doubt?
Sir, I have sent you checked.
Yeah.
So did you get my answer?
Just 1 minute. Salman, we will start in just 3 minutes. Will you please rejoin in 3 minutes? Salman? Okay, Juan. Send me your answer in chat box. Have you all solved this particular part?
Sir, the fifth one, pressure, stress, and what's the third one?
Pressure, stress, modulus of elasticity, and volumetric energy density.
Volumetric energy density.
Yeah. This volumetric energy density in terms of electrical term is represented by half epsilon naught E square, and in terms of magnetic term is represented by half B square over mu naught.
What about the modulus of electricity? What I cannot see in the bracket. What you have wrote?
Y is Young's modulus, beta bulk modulus, and G shear modulus.
Okay.
Aisha? Have you solved?
Sir, I'm doing.
Kezia?
Sir, I'm doing.
Okay. You have to just put the dimension of force and dimension of area, and just you have to simplify them.
Yes. Area means, sir, it is L square. Then
Shakirullah, you have solved.
what, sir?
You have already solved. And you have sent your answer.
Sorry, sir. Sir, my ones is correct.
Yeah. Abhi, have you solved? Just see here, F is force. We have dimension formula for force as this. And in the last page, I have defined you the dimension formula for area as L square. So just put them here. So it will be MLT to the power -2 divided by L square. Okay, Aisha?
Yes, sir.
Now we have L in numerator and we have L denominator. So if base are same and they are in division, so their power would be subtracted. So it will be M L to the power 1 minus 2 will become -1, and T raised to the power nothing but -2. Is it clear to everyone?
Yes, sir.
Joan?
Yes, sir.
So the dimension formula of pressure is nothing but ml minus 1, T minus 2. Okay, Faiza?
Yes, sir.
Okay. So do you have any doubt from today's class to anyone of you?
No, sir, thank you.
Okay then. So we'll stop here. We'll continue in our next class.
Okay, sir.
Okay then.
Okay, good evening, sir.
Thank
Good
you, sir.
evening.
Good evening. Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Now we should leave, yeah? So now we should leave.
Yeah. Shakirullah, just leave.
Sorry, sir. Task barrier was